Hello everyone. Welcome to this tutorial session 11 on the course Mechanics of Solids, having the course code NOC-24 CE76. So basically, before starting the class for today's session, we'll first discuss the contents of week 11 lectures. Mostly, this will be like if you are having any doubts related to week 11 lectures, you can ask me. If there is no doubt, then basically we'll start with the SFD and BMD part, which we have discussed in detail in the previous section, that is tutorial session 10, I guess. So that will form the base for today's session. And after that, we will deal with some of the problems related to stresses in beams. Basically, we will deal with the bending stress in beams and how to determine the bending stresses and the questions related to that, followed by some shear stresses in beams problem, where we have to determine how the shear stress is varying for a given section of the beam and given type of the beam. Okay. So before starting the lecture, please let me know if I am audible and visible or not to everyone. Please type it in the chat box. Okay. So shall we start? Okay. So now, as I said, before going to the question answer round, I should take some of the queries if you people have from the week lectures, that is week 11 lectures. So now you can ask me if you have any doubt or any queries related to week 11 lecture. If there will be no doubt, then I will assume that you know all the concepts of week 11 clearly, so that we can directly move on to the problems. If you have any doubt, please post it in the chat box. So basically, I have a question for you all. I want to know, is the previous session in which we have discussed the concepts, whole concept related to how to draw shear force diagram and bending moment diagram. I want to get some feedback if that was needed or not. Because in today's session, that will form the basic of the stresses in beams. Because if you don't know how to plot shear force diagram and bending moment diagram, then you will face difficulty in calculating the bending stresses and shearing stresses that are coming on the beam. Correct? That was the main reason of focusing a single session on shear force and bending moment diagram. So, as I see, there is no doubts as such. So let us proceed to the problems directly. Note down this question 1 for today's session. Is the question visible? Is my slides visible? Okay. Please note down the question, read it carefully, and try to identify what is the objective of the current question. In this question also, before finding out the objective, one hint I want to give is that You have to draw the SFD and BMD for the given beam in order to proceed to the final objective what they are asking in this question. That is the maximum value of shearing and normal stresses in the beam. So let us read the question. Uh, The question says a timber beam AB of length L and a rectangular cross section as shown in the right hand side having a width of B and height H. That means the lateral cross section, the length of lateral cross section, one is H and one is B. And the longitudinal length of the beam is L. The left portion of the beam is named as A and the right portion is named as B. And in between that, there are two supports, one at C, which is a hinge support, and one at D, which is a roller support, respectively. And the entire span of the beam is loaded with a UDL of intensity W. Correct? Which has been shown in figure 1. So this is the figure 1 that has been shown here. Now, the question they are asking is determine the ratio of maximum values of the shearing and normal stresses in the beam for this corresponding loading diagram. Is the question clear? So basically, we have to find out the maximum value of shearing and the normal stresses in the beam. So for that, we have to calculate first the maximum or the absolute value of the bending moment as well as shear force in order to proceed to find out the shearing stresses as well as the other stress, that is the normal stresses in the beam, or you can call as bending stresses in the beam. Correct? Now, so how to proceed? Yes. So in order to proceed, first of all, we need to find the support reactions at in support C and roller support D. So to find out that, what we can take into account, we can use the equations of equilibrium. So now, if we use now the equations of equilibrium, we can write summation of Fx equal to 0. So from here, what you will get CH or Cx equal to 0. Similarly, if you write summation of Fy equal to 0, you will get Cv plus dV equal to 0. So, summation of Fy equal to 0. So, from here, you will get Cv plus dV equal to 0, where Cv is the vertical reaction at joint C and dV represents the vertical reaction at joint D. So, let us write that equation. So, let this be equation 1 and let this be equation 2. Correct? Till this point, is everything clear? And this Cy plus dy should be equal to the total load that is coming on the beam, that is W into the total length of the beam is L. So let this be equation 2. Correct? Now, can we write summation of moment about point D equal to 0? if we write that, or let us take the summation of moment about point C equal to 0. If we do that, we will get, and I am taking clockwise movement to be positive, minus dy into what will be the lever arm? It will be L by 2. Again, minus W into L into what will be the lever arm for this load? It will be L by 2 minus L by 4. So, sorry, it will be from here to here, it will be L by 4 plus L by 4. So, L by 2, that is L by 2 from the left portion A. So, L by 2 minus of L by 4 will be L by 4, and that will be equal to 0. Is this equation clear to everyone? Let this be equation 3. Now, if we solve this third equation, what we are going to get? We are going to get the value of dy. So, if let us solve that equation, then so we are getting, after simplification, dy into L by 2 plus WL into L by 4. So, WL square by 4. Equal to 0. So dy you will be getting minus WL, sorry, you will be getting dy into L by 2 plus WL square by 4 equal to 0. So upon simplification again, you will be getting minus WL square by 4 So we will end up getting this. So now dy will be equal to this minus WL square by 4 upon L by 2. So one L will get cancelled out and it will be minus WL by 2. Till this point, is it clear to everyone? Now, if you are getting dy to be minus WL by 2, then what will be the value of Cy? How to calculate? Yes, just substitute the value of dy in the second equation, you will get Cy. So please do that and let me know what value you are getting. Actually, this will be positive because it will form a clockwise movement. So if we do some modification here, it will be minus. Again, this will also become minus. So now dy will be equal to WL square by 4 into 2 upon L. So basically you will get, upon simplification, directly WL by 2. Okay. So now just substitute this in second equation. What you are getting, please let me know in the chat box. So we will be getting dy equal to WL square by 4 into 2 upon L. So it is equal to WL by 2. Now you will be able to see that the beam and the load is symmetric in nature about its vertical axis. So if that is the case, then both the support reaction will become equal. So dy, if dy is coming out to be WL by 2, so Cy, after substituting in equation 2, or you can sense that it will come out to be WL by 2 respectively. Till this point, is it clear to everyone? So when query is coming, why one part is negative, other part is positive? So please check. dy is acting at joint D. And if you put your thumb at joint C and try to rotate about that point C, so that uh, the roller reaction, the vertical reaction at D, what is coming out, will try to rotate the entire beam in anti-clockwise fashion. And we are assuming that our clockwise movements are positive in nature. If dy will try to rotate the entire beam in anti-clockwise fashion, so we are taking the sign to be negative. First point is clear. Second point, you check the whole load in the span W. If you consider its area, so it will be W into L, and it will be acting at the center of the span because the whole load is acting throughout the span length. Correct? So W into L will be the total load, and it will be acting at the midspan, that is L by 2 from joint A. Correct? Now, that point load will try to rotate the entire beam in clockwise fashion. So we have taken WL into the lever arm, that will be half of the span length minus L by 4, will try to rotate the beam in clockwise fashion. So we have taken positive sign convention for them. And both the combination will become equal to 0 because joint C is hinge or pinned support, and bending moment at that joint will be equal to 0. Correct? Now, after that, we did all those mathematics and we have found dy to be WL by 2. So, is the doubt clear? Y plus and minus has been taken respectively for dy and the load WL. Okay. Shall we proceed further? Or is there any other problems you are facing? Okay, write it down quickly then. Now we have got both the support reactions. Now what we have to do? We have to plot the diagrams, that is shear force and bending moment respectively for the entire span. So how to do that? We have discussed completely in the previous class. Now please tell me how to do that. In the meanwhile, let me add some slides because it is a lengthy question. It will take some more slides. Okay. By taking sections at three different portions of the span, that is one between A to C, one between C to D, and one between the rest of the span. Okay. So shall we start? Okay. So between section A to C, I have given the name to be 1, 1, section 1, 1. Okay. Now, where that section X will vary from 0 to L by 4. Now, I hope these equations are clear to everyone. So, I am writing it quickly. Just take a note of those equations. Okay. So, we can draw the free body diagram for that span. It is like UDL is acting, and this is the section we have shown. So this is W kilonewton per meter. So this is Vxx, because to keep the whole system or the part of the system in equilibrium, internal reactions are a must, because those are the things that will try to keep your beam in equilibrium. Is this diagram okay for everyone? So these are the internal reactions. Any other reactions which we are missing in this part, please let me know now. Clear? So write the equation for Vxx now and Mxx now. For this section 1, having a UDL of W kilonewton per meter for a span length of X, where X varies from 0 to L by 4. So let us write what will be Vxx. Please tell me. Please tell me the equation for Vxx. Tell me. It will be minus W into X. Is the only reaction that will be acting on this span. And why minus? Because Vxx and Wx are acting on the same direction. So if you take one entity on left hand side, the other entity when it goes to the right hand side will automatically become reverse of the sign convention that you have followed for Vxx. So Vxx now will be equal to minus W into X. Now, write the equation for Mxx for this section. Now write mxx equation, please. Everyone has written. Please check the equation with me. Minus w into x is the vxx. Now mxx will be equal to minus w into x is the total load, and what will be the lever arm? It will be x by 2. So w x square by 2. Correct? Now tell me at x equal to 0, vxx will be equal to 0. mxx will be equal to 0. At x equal to L by 4, your vxx will be equal to how much? Minus wl by 4, and your mxx will be how much? Please tell me. Please tell me. Yes, correct. Wx square by 2. So just tabulate all those important points. Then we will proceed to the next one. Sorry. Just fill those values and let me know in the chat box. After that, we will move to the other section. Till this point, everything is clear to everyone. Now, please write in the chat box if it is clear or if you people have any doubts. Okay. Now, similarly, can you write for section 2.2, where section 2.2 will be between C and D, and where X will vary from L by 2 to L by how much? L by 4 to 3L by 4. Is this clear? Now draw the FPD again. So this time the UDL will be there along with a reaction of WL by 2 at joint C. So here you have cut a section. So the internal reaction will again be same, VXX and MXX. Now, tell me the equation for VXX now for this section 2.2. It will be W into X minus W into X plus WL by 2. So if you simplify this equation, it will be minus WX plus WL. Clear? Is this equation clear to everyone? Okay. So now write for MXX then, ending moment equation at this section. How much you will be getting? You will be getting how much? It will be WL by 2 into what will be the lever arm? It will be X minus L by 4. Then minus of WX into X by 2. Correct. Now, just substitute the upper and lower bound value and get me the quantitative values of Vxx and Mxx at L by 4 and 3L by 4 respectively. So, at x equal to L by 4, what values of Vxx we will be getting? Just substitute L by 4 at x equal, just substitute L by 4 at Vxx equation. You will be getting WL by 4. Everyone is getting this. And if you substitute MXX, what you will be getting? You will be getting a big equation. So simplify it carefully. So minus WL by 4 whole square. Please tell me how much you are getting. So you will be getting minus WL square upon 16 into 2, that will be 32. So minus WL square by 32. Because the second term will become 0 as soon as you substitute x equal to L by 4. So it gets simplified further. So WL by 4 whole square upon 2 will be equal to minus WL square by 32. Correct? Now, similarly, substitute x equal to 3L by 4 and get me the values of Vxx and Mxx respectively. So, at x equal to 3L by 4, what you will be getting? Minus 3 WL by 4 plus WL by 2. So, minus 3 WL by 4 plus WL by 2. So, 75 minus 50. So, minus WL by 2. So minus W into 3L by 4. So just simplify and give me the final value. Minus WL by. So Vxx you got minus WL by 4. So what will be the value of Mxx now? Please tell me. Please tell me what will be the value of Mxx. Just substitute x equal to 3L by 4 in the second equation, that is Mxx, and give me the final value. So you will be getting minus W by 2 into 3L by 4 whole square plus WL by 2 into 3WL by 4 minus L by 4. So just simplify. You will be getting from first component, it will be 9L square by 16. So minus 9W L square by 32. So first component will be minus 9WL square by 32 plus WL 2W 3WL by 4 minus L by 4. It is 2WL by 4 or WL by 2. So 3L by 4 minus L by 4 will be 2L by 4. So 2L by 4 upon simplification became L by 2. So L by 2, L square by 4. So WL square by 4. So minus 9WL square by 32 plus WL square by 4. So minus WL square by 32 here. Many are writing that one, so it will be correct. So we are getting the final value H minus 9WL square by 32 minus or plus WL square by 4. So finally, we are ending up at minus WL square by 32. Okay. So that's the end of section 2.2. Now we have to do the same thing for another section, that is 3.3, for the rest of the beam. So just see the beam, UDL is there. So same steps we need to follow. So section 3.3. Okay. Write the equation for section 3.3. Please write the equation for section 3.3. First step, draw the FBD for that portion. Show the internal reactions. Then calculate the equation for those internal shear force and bending moment in terms of span length, that is x. So here x will vary from 3L by 4 to the total span L. Now we have to draw the free body diagram. So UDL is there completely. So you can draw the UDL like this. Now one support reaction WL by 2 will come at L by 4. Another support reaction will come somewhere here. Now now check, is the FBD okay for everyone or there is some issue? We have shown every reactions, every loading condition that will be coming to the left portion of that section 3,3 along with the internal reaction Vx and Mxx. Now tell me the equation for Vxx. It will be WL by 2 plus WL by 2 minus W into X. So it is WL minus WX. Similarly, MXX, you tell me the equation, it will be WL by 2 into X minus L by 4 plus WL by 2 into X minus how much? 3L by 4. Complete the equation. So are you getting these equations? Just check. Or else if you have any doubt, please let me know now in the chat box. Are these equations clear to everyone? If no, please let me know now. Okay. So I hope the equation is clear to everyone. Now do the same part. Substitute the lower bound and the upper limit in both the equation and find out the values of Vxx at x equal to 3L by 4 and Mxx at x equal to 3L by 4. Similarly, at x equal to L, the Vxx value and Mxx value respectively. Do that. After that, we will plot the SFD and BMD and we will check how the curvature is coming. Okay. Now I am writing it here. At x equal to 3L by 4, your Vxx is coming out to be WL minus 3WL by 4. So it is WL by 2. Then Mxx is coming out to be how much? If x equal to 3L by 4 minus W into 9L square upon 16 into 2 plus WL by 2 into 3L by 4 minus L by 4 is 2L by 4 and L by 2. And the third component will become 0. So please simplify and tell me the value. It will be 9 upon 16 plus 1 upon 4 WL square. Sorry, 9 upon 32. It will be 9 up minus 9 upon 32 plus 1 upon 4. So minus 1 by 32 WL square. So I am erasing all these parts and writing the value directly. Okay. It will be minus WL square upon 32. Now, similarly, at x equal to L, that is the final point, what will be the value of Vxx? It will be WL minus WL. So it is W times L minus L equal to 0. Similarly, at x equal to L by 4, what will be the value of Mxx you are getting? Just tell me. It will be minus WL square by 2 plus WL by 2 into L minus L by 4 plus WL by 2 into L minus 3L by 4. So upon simplification, it will be minus WL square by 2 plus WL by 2 into 3L by 4. So 3WL square by 8, then plus 4L minus 3L, L by 4. WL square by 8. So 4WL square by 8 each. So everything will get deducted and you will be getting Mxx equal to 0. And obviously at the end point, since there is no support, so it is a free support. So the bending moment at that point B should be equal to how much? It should be equal to 0. And rightly we are getting the value to be the same, that is 0. Now let us plot the FBD and BMD, sorry, SFD and BMD for this given beam and check what can be done further? Now, this is the UDL on the complete beam. And these are the L by 4, and between them the length is L by 2. Am I writing it correctly or wrong? Just check. And this is again L by 4. So now this is W kilonewton per meter. So now just plot the BMD and SFD for this beam throughout the span length and find out the maximum bending moment and maximum shear force. Before that, let us draw the SFD and BMD. So how we are getting? Wait, we have mistakenly added more slides than required. Okay. Now everything is clear. So now this is your beam. Sorry. Now this is WL by 2. This is WL by 2. So now if you draw the SFD, how it will look like? It will look like it is it is going from 0 at x equal to 0, Vxx is 0, and at x equal to L by 4, Vxx is minus WL by 4, and your original equation for that section is minus W into x. Okay. So if that is the case, the slope will be negative and it will move downward from the reference axis, that is 0, 0 for SFD. Okay. till this much we have identified what to do. Now let us do that, then we will proceed further. Ah, between the at the section 2 2, what is our equation? It is minus wx plus wl by 2, and at x equal to L by 4, we are getting WL by 4. And at x equal to 3L by 4, we are getting Vxx to be minus WL by 4. That means it will go up to the positive side to WL by 4. And again, it will come down to minus WL by 4 at x equal to 3L by 4. Then similarly, when you check for section 3 at x equal to 3L by 4, Vxx is WL by 4 again. So it will again move upward, cross the reference, and will go to WL by 4 respectively. Then it will touch the zero value at point right. So this is negative, this is positive, this is negative, this is positive. And the values are minus WL by 4, minus WL by 4, WL by 4, WL by 4, and 0, 0 respectively. Now, so from this SFD, you can identify that your absolute shear force maximum will be WL by 4, which will be taken into account for the next part that we have to calculate. That is the shearing portions. Now, this is the reference line for BMT. Now draw the BMT for the given beam. Now check. At x equal to 0, your bending moment equation is minus Wx square by 2. That means it is a parabolic equation. So a 2-degree curve will come. So now the doubt will arise that will the curve from 0 to how much? Minus WL square by 32. Will the curve be concave upward or concave downward? So two cases might arise. Now how to check this? I have already stated in the previous class. Just check that for that portion, your shear force values are negative, and the negative value is going on increasing from when you move ahead. That means the slope of the bending moment diagram will be such that the slope will be negative because the shear force values are negative, and the slope will gradually increase because the values are increasing for the above case. So from this case 1 and case 2, The first case seems logical, but we don't know. The second case is okay, but you can find out that your slope is decreasing, which is not possible. So the first option is correct. So you will be getting the curve like this. Okay. Since the loading condition and the beam is symmetrical, your SFD will be anti-symmetrical, and again your BMD will become what? It will be symmetric or anti-symmetric? Just tell me. Correct. So every even order terms will match their counterparts. That means if the load is symmetric, the SFD will be anti-symmetric, and again BMD will match the loading pattern. But the other way around is not. Okay. Now, for the second section, our equation is again the highest order of x is 2. That means a parabolic curve will come, followed by the third section will also contain a parabolic term. So every curve will be parabolic in nature, and in the section 2, we are getting at x equal to L by 4. Our bending moment is minus WL square by 32, and at x equal to 3L by 4 also, we are getting our bending moment to be minus WL square by 32. Now, just check if this equation at some x between that range, is the bending moment becoming 0 somewhere? Now, the major question is that, is the bending moment becoming 0 somewhere? We have to check that. Just equate that equation equal to 0 and check if any x which lies between the interval L by 4 to 75% of L is falling within that range or not. If not, then there won't be any point of 0 bending moment. Okay. Just check. Just put this mxx equal to 0 and find the value of x. If you are getting any x that lies between this region, then there will be a point where your bending moment will become 0. Otherwise, there won't be any point existing in that span where the bending moment will be 0, apart from the extreme points, that is A and B at x equal to 0 and L respectively. Okay. Now, so you take it as an exercise and do it, as I know there won't be any point of 0 bending moment between this mid span region. So I am directly drawing the figure. Okay, this will be your bending moment time, and your maximum bending moment will be WL square by 32. And we are taking the mod of maximum bending moment, that is absolute maximum bending moment throughout the span, is WL square by 32, which is occurring at the two supports, that is C and D respectively, located at L by 4 from either end, or L by 4 and 3L by 4 from left part A, or left support A, which is a free overhang B. Okay. Now, we have calculated the absolute maximum shear force and absolute maximum bending moment, or maximum shear force and maximum bending moment that is occurring for the given beam. Now, we have to determine the maximum value of shearing force and normal force in the beam. Now it is relatively straightforward. We know M by I equal to sigma bending by Y. So you have to calculate sigma here. So it will be M by I into Y. And M is WL square by 32. I will be how much? It will be BD cube by 12 for a rectangular section. So BH cube by 12 into Y will be H by 2. Now just simplify this and tell me the value of the maximum bending stress you are getting. So it will be WL square by 32 into BH cube by 12 into H by 2. So it will be 12 by 64. 12 by 64. So 6 by 32 or 3 by 16. 3 by 16 W L square upon BH square. So you are getting 3WL square by 16 BH square. Okay. So the maximum bending stress that can be found in this type of beam is 3WL square by 16 BH square. 3WL square upon 16 BH square. Similarly, this is sigma max bending. Now, similarly, tau max we will find out by VAY upper by IB. So V, you have to substitute V max, that is WL by 4. I will remain same, that is 12 upon BH cube. I am directly reversing the order. 1 by B will remain 1 by B. Area will be B into H because it is a rectangular section. Cross section is rectangular. And Y bar will be how much? It will be H by 4. Y bar is nothing but when you have a rectangular section, your neutral axis will lie at the mid depth. So your top portion will be having H by 2 depth. So for this hashed portion, you have to take the movement of the area of this hashed portion about neutral axis, which will be lying at its centroid, that is at a distance of H by 4 upon 2. That will be H by 2 upon 2. So H by 4. Getting? Is this clear? And I have seen this part has been taught pretty well in the lecture series also. So upon simplification, what we are getting, just simplify it and get me the value. It is coming out to be 12 by 16. 12 by 16 W B H square upon B H cube. So 12 upon 16 W H square by H cube. So 12 upon 16 W by H. So now we have calculated sigma max bending and tau max shear. So now what we have to do? we have to take the ratio of maximum shearing stress to bending stress or normal stress. So maximum shearing stress to normal stress, we have to report the ratio. So tau is 12 by 16. So it will be 3/4. 12 by 16 W upon H. Please substitute it carefully, otherwise we will be getting wrong values. So 12 by 3 will become 16 will get cancelled out from both top and bottom. W will get cancelled out. So we will get 12 by 16 W upon H into 16 by 3 PH square upon WL square. So we will get 16 will get cut, W will get cut. So just simplify it and tell me the value. So it is coming out to be B H square, means 12 by 3 will be 4 B H square upon HL square. So it will be 4 B H upon L square. So we are getting the ratio of shear stress to bending stress or normal is equal to 4BH upon L square. Just check it. If we are getting it correct or wrong, just simplify it and tell me the value if you people are getting this value or not. Okay, this is the value everyone is getting. Okay. So the final answer is this: tau max upon sigma max we are getting to be 4BH upon L square. Just simplify this tau equation once more. I think we have missed this W part. So 12 will go upward. 4 into 4, 16 will come downward. And it will become W L B H into H upon B H Q into B. So H square upon H cube will become 1H. So W L H H is H. W L 1B will get cancelled out. So H cube 1B will get cancelled out. So WL upon BH. And this will be 12 by 16. So basically, we will be getting tau max to be 12 WL upon 16 BH. And M sigma max bending, we are getting 3. Check this one more time, then we will conclude if we have done, if we have simplified everything correctly or not. There are so many terms, that is the reason we have done it. So you will get here 12 upon 32. 12 upon 32 WL square upon BH cube into H. So 12 upon 64, 6 upon 32, 3 upon 60. 3 upon 16. WL square upon, yes. This we have done it correctly. Only thing there was a mistake was in shear stress part. Now you take the ratio, you will end up getting correct values. Okay, 12 upon 16 will become 3 by 4. Divided by 3 WL square upon 6 BX2. So we will end up 4 times H upon L. Okay. So we are getting tau upon sigma to be 4 times of H by L. So this is the final answer. Is this clear? Is this question clear to everyone? So while solving this type of questions where no numerical quantities are there and the quantities are something like descriptive type W, L, B without any quantitative value, then you be careful while simplifying this equation. Otherwise, you will do the same mistake as you have done it here. So just try to simplify it as much as possible and then take the ratio. So you will end up getting the right value. Okay. So now let us move to the next question. So this is the part 2 or second question of today's session. So here they are asking determine the depth h and width b for that same question having a rectangular cross section. Given that L is 5 meter now, W is 8 kilonewton per meter. So write the given part. L is now given. Intensity of the load is given to be 8 kilonewton per meter. Tau max and sigma max both are given. So right now we have tau upon sigma equal to 4L by H. So just substitute 1.08 by 12 equal to 4H upon L. So if you are doing this, so 1.08 upon 12 equal to 4 into H upon 5. So from here, what will be the depth of H? Just calculate. So H we are getting 0.1125 meter. Is this clear? So once you are getting this part, so you are done with the depth H. So now we have calculated what will be the value of H. So 4. So upon solving, we are getting H to be 0.1125. So determine the depth H and width B. So one part we have calculated, that is the depth h. Now we have to calculate the width b. Now you check, you have the equation for tau max to be 12 WL upon 16 BH. Tau max is 12. First write sigma max is equal to 3 upon 16 WL square by 6 PH square. So sorry everyone, there was a network problem from my side, uh, due to which I got disconnected. I have messaged everyone. Now, after 2-3 minutes, we will start the session. So let us wait for 2-3 minutes so that everyone can join. Then we will continue this session. So in the meanwhile, let me write all those equations from previous slide. Yes. Meanwhile, you people can try solving this question out. Actually, we have calculated H value, which came out to be 0.1125. Now, what we have to find is, we have to calculate the width B. Now, substitute every value. We know the value of W, that is 8 kilonewton per meter. Length is 5 meter. B is the only unknown term. H square, H you know from this answer. And sigma max, we know that is 12 MPa. From this equation, you substitute everything and give me the value of B. That will be the second part of the answer for this question. Okay. Similarly, if someone wants to try with tau max also, they can also try, because tau max is 12 by 16 BH. So from here also, if you see, tau max value is known, length is known, W is known, H is known, the only unknown is B. So either of the equation will hold good to calculate the second part, that is the width of the B. So let us try with this equation only, that is 12 equal to 3 into 8 kilonewton per meter, length is 5 square, 16 into B into 0.112. So from here, tell me what is the value of B you are getting? Is 3 into 8 into 5 square upon 16 into 0.125 into 2. So we are getting B to be 27. One thing you have to take care of here is the units. Now 8 is in kilonewton per meter and sigma max you have calculated in MPa. So to make it in kPa, it should be 12 power 3. Now you calculate the value of B. Now every unit is consistent for this part. Now you calculate what will be the value of B. So we are getting B to be 0.0277 meter or 27.7 mm. Okay. So we got H, we got B. So I hope this question in total is clear to everyone. Please note it down so that we can proceed to our next question. Is it over or is there any doubt? No doubts? Okay. Read this question. This is the third question for today's session. So in this question, basically they are asking to determine the horizontal line along which the shear stress will be maximum. So first thing is you have to identify at which depth the shear stress will come out to be maximum. Second thing, substitute that value in your equation for shear stress and calculate the maximum value of stress. Okay. So now this is a kite shape. Cross section has been given. Means a beam having a cross section of kite shape has been shown in figure 2 is subjected to a vertical shear. So first thing you have to determine the horizontal line along which the shear stress is maximum. How to determine? So now let us draw this figure once more here. For this type of shape, we know, let us write all those things, what is required. I will be 2 times of B into H cube by 2. So BH cube by 6. Now, what else is required? Now you see, in the previous question, actually, it was a rectangular cross section in which along the depth, your width of the section was constant. So as you vary the H, your B was constant. But when you check this question, you will find that as soon as your H varies from this bottom to top, your depth is gradually, your width is gradually varying. That is B. B is maximum at the center, and from or for either side, it is reducing. So let us first take one line, arbitrary line at a depth y. This is H. So this is H. So let us take one arbitrary line which is at a depth of y from bottom. Now, so from similarity of triangle, you can find the width of this line at a height y. So you can see for a depth of h, your width of the portion is b. So for h meter height, your width is b. So for 1 meter, your width will be b by h. And for y meter, your width will be b by h into y. So let this width be some letter say uh, L prime, or let us say A. So A, let us say A. So A becomes by by h. Okay. Now A is by upon h. A equal to by upon h. And this A is not area. A is, let us change this A also, because A we have to represent for area. Let this be B. So this became B. Okay. Now tell me what will be the area of the shaded portion. Area of the shaded portion will be half into B into Y. So it will become half into by upon h into y. And the neutral axis will pass through the mid, that is at a depth of h from bottom or h from top, because it is symmetrical about that axis. Now we know tau equal to VA y bar upon IB. Correct? This is the equation. So for this, we need to calculate I first. I will be twice of BH cube by 12, which will be equal to BH cube by 6. And your B is a function of Y, which will be equal to small b y times small b y divided by h. And your y bar is the movement of area of this shaded portion about neutral axis. So your y bar will be, first check, h minus of 2/3 of y. Is this correct? Correct. So now you just substitute everything in the equation of tau, as we have learned earlier. Tau will be VA y bar upon IB. So V remains V because vertical shear is V. A is by square upon 2h. Y bar is h minus 2 by 3y. half by upon h into y into y bar is h minus 2/3 of y. Then I is bh cube by 12 into 2. And what will be capital B? It will be by upon h. So just simplify this and give me the value of tau in terms of small y. Okay. Just simplify this and provide me the value of small y. In the meanwhile, okay, let me add one more slide. Till this point, is it clear to everyone? So let me note everything down over here. So it is V A y bar upon I B. So V remains V, by square upon 2h. So just simplify and give me the value of tau as a function of y. So V by square upon 2h these are some of the most difficult question in this chapter because many calculations are there where we can make mistakes. That is the reason you should do it carefully. Otherwise, mistakes are bound to happen. It is sure that you will create some unnecessary mistakes. And that is not new. That happens with everyone. Okay. So now you check V remains V. V remains V. 1 by 2 into 2 became 4. 12 went to top, so it became 12. 12V by 4. So 3V. This got cancelled. So 12 upon 4V y into h minus 2/3 of y by bh cube. Correct? So it became 3Vy h minus 2 by 3y by bh cube. So 3V, so 1 by bh cube, you can take it out. 3Vyh minus 2V y square. Now for tau to be maximum, you can write dou tau upon dou y equal to 0. If you do that, you will end up getting 1 by bh cube times 3 Vh minus 4Vy will be equal to 0. From here, if you see, you are getting 3Vh equal to 4Vy or y equal to 3 by 4h. So you are getting upon simplification y equal to 3 by, sorry, uh, you are getting y equal to 3 by 4h. And this 3 by 4h is from one of the corner tip. So either bottom tip or top tip. So from neutral axis, if you want to write, what will be the distance? It will be tau max will be at plus or minus h by 4 from neutral axis. Okay. So the correct answer is if you go h by 4 up or h by 4 down from neutral axis, you will end up getting the maximum shear stress at that depth to be maximum. So when you substitute this y equal to plus minus h by 4 in this equation of tau as a function of y, you will get the maximum shear stress. So this is the fourth question they are asking. So tau max equal to k times of v by a. So what is k value they are asking? And you have the equation as tau max is 1 upon bh cube times 3vyh minus 2vy square. So you have the equation as 3vyh minus 2vy square upon bh cube. So you will be getting 3ey upon bh square now. Tau max will be at y equal to plus minus h by 4 will be equal to 3vy by bh square So equation of tau is 3vyh upon bh cube minus 2vy square upon bh. So if you simplify this, h will get cancelled. So it will become square. So 3vy by upon bh square upon 2vy square upon bh cube. Now at the place of y, put h by 4. So 3v h by 4 upon bh square minus 2v h square upon 16 by bh cube. So what we are getting? 3v upon 4 3v h by 4 upon bh square minus 2v h square upon h square upon 16. So just simplify and get me the value what we are getting. So we are getting 3 by 4 v upon bh. 3 by 4 V upon BH. If not for that, it will be equal to 3V H by 4 upon BH square minus 2V by 16. 2V by 16 means it will be V upon 8BH. And from here, you will be getting 3 by 4 V upon BH minus V upon 8BH. So 3V, 6V minus V, 5V upon 8BH. It will be 3H by 4 because Y we have taken from the bottom side. So it will be 9VH by 4BH square minus 2V 9H square by 16 by BH cube. So from here, if you substitute, it will be 1.125 or so 9 upon 4 V upon BH minus 18 by 16. So 9 by 8 V upon BH. So you will be getting 9 by 8 V upon BH. So tau max will be equal to 9 by 8 V upon BH. And V upon BH is nothing but tau mean or V by A. So K value we are getting 9 upon 8. So the answer for this question is 9 by 8. So K value is 9 by 8. The only thing you have to identify here is that what should be the value of Y. Since Y we have measured from this tip of either side to the zone where we have written this capital B. So we have to take the Y value we have got after differentiating with respect to small y. So Y we have got 3 by 4H. So upon substituting this 3H by 4 in tau, you will get tau max that we are getting 9 by 8 V by BH. So V by BH, BH is the area, so it is V by A. So if we have to write tau max in terms of kv by a, we are getting tau max to be 9 by 8 v by a or v by bh, which can be written as 9 by 8 v by a. Clear? So they have given that we have to write tau max in this term, that is k upon va. And we are getting upon simplification tau max at y equal to 3h by 4 as 9 by 8 v upon bh. And you can substitute bh to be a. So 9 by 8 v by a. Now, upon comparison with the question given, you are getting k value to be 9 by 8, that is 1.125. Correct? So your max tau max will be 1.125 v upon a, and it will occur at a depth of 3h by 4 from tip, or plus minus h by 4 on either side of the neutral axis. That means plus h by 4 represents above the neutral axis and minus h by 4 represents the bottom portion. Correct? So note it down. Okay, done. Now, try this question. In this question, they are telling, determine the dimension A of a beam having a square cross-section in terms of the radius r of a beam with a circular cross-section. If both beams are subjected to same internal moment, which results in same maximum bending stress. That means we have a beam which have a circular cross-section having radius r, and again we have a beam of square cross-section whose dimension is a. Means all the four sides have a dimension of a. And both the beams are subjected to the same internal movement. So m is constant, which results in same bending stress. That means sigma bending, that is bending stress, sigma b is also constant. So if they are it is given in the question, sigma b for square will be equal to sigma b for circular. Okay. That means m by I into y max will be equal to m by I into y max for circular. Okay. So m is constant, they are telling. I is how much for a square cross section? It will be a power 4 by 12. Y max will be a by 2. M will remain constant. This, how much will be the moment of inertia for the circular cross section? It will be pi by 4 into r power 4. And it will be r by 2, y max. So m and m will get cancelled out. That means we will be left over with 6m by a cube will be equal to 2 upon pi m upon r cube or r power 4 into 1. Just check. Can we write this? It will be 12 or 12 m a upon 2 a power 4. So it will be 6m by a cube will be 2m r by pi r power 4. So 2m r by pi r cube. So r will 1 r will get cancelled out. So m and m will get cancelled out. So 6 upon a cube, we are getting 2 upon pi r cube. So 6 pi r cube equal to 2a cube. So they are asking 6 pi r cube by 2 whole power 1 by 3 will become a. So a will be nothing but 3 pi power 1 by 3 into r. So cube root of 3 pi. So what will be the cube root of 3 pi? 2.11 r. This implies you will end up getting a to be 2.11. Correct? So A will become 2.11. That means to get same internal movement which will result in same bending stress, you have to design the square cross section to be equal to 2.11 times R. Then both the circular cross-sectional beam and square cross-sectional beam will take or provide you or take the same bending stress, which will be highest. Correct? So in this question, basically they were asking to determine a relationship between both type of beam such that the components such as internal movement and stresses will remain constant. So if you design the square beam having the sides length as r times 2.11, you will end up getting maximum bending stress, which will be equal for both circular one, square one, as well as circular. Okay. Is this question clear? Here it has been written A equal to 2.11 R. Please note, I have written it in small letters. A equal to 2.11 R. So let me make it big. It will be A equal to 2.11 R. Is this clear? Shall we proceed to the next question? Okay. So I am moving forward to the next question then. I hope everyone must have noted it down. Read this question. This question is similar to what we have solved earlier in this tutorial session. The first question or second question maybe. In this question, they are asking, this is a rod AB, which is horizontal, having a smooth journal bearings at A and B that only exert vertical reaction on the journal. Determine the absolute bending moment along the beam. So basically, the first thing you have to draw the FBD of this beam. You have to calculate the support reactions. After calculating the support reaction, identify the maximum bending moment that will come in this beam. Okay. So let us do it quickly. Now, I am not, or let us draw it here. So FBD will come something like this. So this is 12 kilonewton per meter. So for from portion A to B, it is what type of load? It is UDL, 3 meter and 1.5 and two reactions. This one. So we can write summation of movement about point A equal to 0. I am doing it directly now because everyone is now capable of solving this type of questions, I hope. Solve and give me the value of RB. So RB we are getting 28.5 kilonewton. So similarly RA will be how much? RA will be 12 into 3 plus half into 12 into 1.5 minus 28. So 36 plus 9 minus 28. 12 into 3, 36 plus 1 by 2 into 12, 1.5 into 0. 12 into 1.5. So RA we are getting to be 16.5 kilometers. So now RA you are getting 16.5 kilonewton. RB you are getting 28.5 kilonewton. So I am erasing this FBD directly to get some space. Now just take one section here and one section here and write the bending moment equation. We don't need shear force equation because we have to calculate absolute bending moment. So we will only plot BMD. For your case, you can try with SFD as well. Okay. So if we take section 1.1 now, so section 1.1 will look something like this. Here it will be 16.5. So here EXX, MXX, distance X, and here it is 16.5 kilometers. So now what will be your value of VXX? Or we don't need VXX, so I am directly writing MXX. Okay. You can write VXX value also. It will be 16.5x minus 12x square by 2. Similarly, when we take for section 2.2, so I am writing for section 2.2 what will be the MXX directly. 16.5x minus 12 into 12 into 3 into x minus 1.5 minus, now you check at 1.5 meter the height is 12. So if you have to write the height at 1.5 minus x, what will be the height? It, this won't be clear in this slide. So let me draw one more slide and let me take one more slide and draw that there only. Otherwise, many doubts will come. Now we can do one thing. If we take from left hand part, it will be pretty difficult. So let us take it from right hand part only. Okay. So that it will be easier. Section 2 from right hand side. Okay. So if we do that, what will be the free body diagram looking like? Now this will be looking something like this. and we are taking x from this side. So mxx will be how much? It will be how much? Minus half. So you see, at 1.5 meter, the height is 12. So at x meter, what will be the height? So 1.5 meter height is 12. 1 meter, 12 upon 1.5. At x meter, it will be 12 upon 1.5 into x. So 12 upon 1.5 means 8. 8x. So your height will be 8x. So minus half into 8x into x into what will be the height? It will be 1/3 of. So minus half into 8x cubed by 3. 8x cubed by 3. So minus 1 by 6, 8x cubed. So minus 4 by 3 x. Okay. So if you put x equal to 0, you will get 0, and x equal to 1.5, you will get minus 4 by 3 into 1.5 cube. So minus 1.5 cube into 4. So minus 4.5 kilonewton meter. Okay. Similarly, when you substitute at x equal to 0, you will get 0, and x equal to 3 meter, what you will get? 16.5 into 3 minus 12 by 2, or 6 into 3 square. Minus 4.5 kilometer meter. Now, so your BMD will look something like this. Your BMD or this beam will be looking something like this. You can try out with all those sign conventions what we have discussed previously, but I am drawing it directly. So this is 0. It will increase. It will go to minus 4.5, and here it will be cubic, and it will reach 0. So this is minus 4.5 kilonewton meter. For this equation, you differentiate once with respect to x to get a maximum x value, where maximum bending moment is supposed to come. So if you differentiate dou mxx by dou x, you will be getting 16.5 minus 12, 12x. So 16.5 upon 1. So at x equal to 1.375 meter, you are going to get a maximum. So you just substitute 16.5 into 1.375 minus 6 into 1.375 square. So 11.43. So at x equal to 1.375, you will get the maximum value, that is 11.43. You will get the maximum value 11.4 kilonewton meter. That is M max. And how we got this? Just you take the mxx equation, take the derivative as I did it here. Dou mxx by dou x equal to 16.5 minus 12x, and equate it to 0, you will get x equal to 1.375. That 1.375 will provide you the maxima for this bending moment diagram within the section A and B. Okay. And we are getting M max to be 11.4 kilonewton meter, 11.25 kilonewton meter, when we are substituting this x equal to 1.375 meter in this first equation of mxx for section 1. Correct? Now after this, you have to calculate. We have got the absolute maximum bending moment will be equal to 11.25 kilometers. Okay. So this is the absolute bending moment. Now, after determining the absolute bending moment, the next part they are asking to determine the absolute bending stress for that absolute bending moment. So we know M by I equal to sigma P by Y or sigma by Y. Correct? M by I equal to sigma by Y. And I for a circular section, we know pi by 4 or pi by 64 t power 4. So you just substitute t. They have given 0.090 meter. So pi by 64 into 0.09 into 0.09 into 0.09. So we are getting 3.2206 into 10 power minus 6. 3.22 minus 6 meter power 4. Now, M we have got how much from previous slide? It was 11.4 kilonewton meter. So 10 to the power 3 Newton meter. 3.22 into 10 power minus 6 meter power 4, and y will be d by 2 will be equal to 0.045 will be equal to 0, and that will provide us the maximum bending stress. Just substitute the values and let me know the answer. So we are getting sigma bending 160,434,782.6 Newton per meter square. So 3 kilonewton. So 160,434 kilonewton per meter square or 160.4 160 MPa. So absolute bending stress in the beam will be 160 MPa. Okay. Is this clear to everyone? So sigma bending, that is the maximum bending stress, will come to be 160 MPa. Is this clear? So with this, we have completed most of the problems related to bending stress and shear stresses. So now, if you have any doubt related to any question solved today, please feel free to post it in the chat box. Or if you have any doubt, please unmute yourself and ask me. Okay. Now the stage is all yours. If you have any doubt, please ask me. If there is no doubt, we will end the session after 2-3 minutes. I will wait for another 4 minutes. If there will be any doubt, I will take those doubts. If there will be no doubt, we will end our session for today here only. I think okay. Just we are getting sigma bending to be this much big quantitative value in Newton per meter square. So just I am converting this Newton per meter square to megapascal. So if you convert that, you have to just shift your decimal point to left side and that will come to be 160 MPa. That is just conversion. I haven't done anything new. Okay. Clear? So I think there is no more doubts as such. So if you have any doubt, you have another couple of minutes, please let me know. Otherwise, I will end the session here. Okay. So thank you everyone for joining the session. So I am closing out the session. You people can now leave the session if you want.